got these solute particles that are interfering with the intermolecular forces of this solvent. And so the attraction is going to be greater. So 101.5. You just add that boiling point elevation. That's why you add salt to icy roads. It will drop the freezing point. Colligative properties are things that only depend on the concentration of a solution and not on the identity of that solute. So one example is freezing point, and this FP means freezing point. So you know the freezing point of pure water would be 0 degrees Celsius. And if we added a solution, our solute, potassium nitrate, we would see a freezing point below that, right, below 0. And interestingly, if we took a different solute but the same concentration, we would get the same freezing point. So this is what we call a colligative property. Let me show you how to predict what would happen with that. Similarly, if you add a solute to a solvent like water, let's say we have water, it will increase the boiling point. Okay, so freezing points get reduced, but boiling points get increased. And you see what's going on here. I've got these solute particles that are interfering with the intermolecular forces of this solvent. And so the attraction is going to be greater. And so it's going to take a higher temperature to boil the solution than the pure solvent. So make sure you remember that the boiling point gets elevated. Okay, so by how much? Well, we have this nifty formula here, and it gives you what we call the boiling point elevation. By how many degrees does that boiling point get elevated by the addition of a solute? So it's the difference in the solution boiling point and the solvent. And you notice we have a constant here, Kb, not the base constant, but Kb. And those are given values for a solvent. You can look those up. We deal with molarity, and then the von Hoff factor is the number of things produced in solution. So if I had a non-electrolyte like sugar here, I is 1 because it stays as one big thing. But sodium chloride, we would split into 2 ions, sodium chloride. Similarly, barium chloride would be 3 ions. So whatever that factor is, you throw that in the equation. So let's do an example here. I've got a sodium chloride solution, and we're going to find the boiling point of that solution. And so the boiling point elevation would be the Kb, so 0.1. Now notice the units here. It's degrees C per molal. The molality of the solution is 1.5 molal. That's given. And then I, in this case, would be 2. And so the boiling point elevation is 1.5 degrees C. Okay, now that's not the boiling point of the solution. The question is, what is the boiling point of the solution? Well, the solvent boils at 100, so 101.5. You just add that boiling point elevation. So the boiling point of the solution is 101.5. It gets elevated. Okay. Similarly, if you add a solute to a solvent, you will reduce the freezing point. That's why you add salt to icy roads. It will drop the freezing point. Similar equation that we have, just like the boiling point one, and this one calculates the freezing point depression. So that's delta TF. And there are freezing point constants for solvents. And so it works just similarly. So let's do an example here. We've got an aqueous solution, so I know that my I is going to be 1. For sugar, it's a non-electrolyte. And so the freezing point depression is, notice that the Kf is negative here. So degrees C per molal. We know the molality is 1.1 molal. I is 1. And so we're going to get negative 2.8 degrees C. Now, pure water freezes at 0. So we're going to freeze 2.8 below that. So the freezing point of the solution is going to be 0 minus 2.8 which is negative 2.8 degrees C. So that's how you use the freezing point, depression, boiling point elevation formulas.